indigenously developed abrasive flow finishing and polymer rheological abrasive medium for finishing of additively manufactured complex features. India is very good in terms of conventional manufacturing. However, if our GDP has to be increased, we have to think about ultra precision manufacturing such as micro nano manufacturing. If we can club micro nano manufacturing to the conventional manufacturing, our GDP can enhance greatly. So, what I am going to talk today is about nano manufacturing, how we indigenously developed semi-solid cutting tools which can compensate to finish simple to the complex surfaces that cannot be finished by any type of single point or multi-point solid based cutting tools such as drills, milling cutters, grinding wheels, etc. How to finish the complex surfaces ranging from engine blocks to the extrusion dies and injection molding dies and other things. These are complex because point to point curvature will change us. So, to compensate incapable abilities of single point cutting tools, what we have developed is abrasive flow finishing process along with a semi-solid to liquid based cutting tools which can flow across the surfaces to polish. So, the nano manufacturing is very important, as you can see the knee implant before finishing and after finishing. So, to finish complex features, single point cutting tool or multi point cutting tool which are solid based cutting tools cannot polish this because of the complexity from point to point on complex features. As the world progresses, the complexity of the component grows, and as you can see in additive manufacturing processes, most of the times people try to make complex internal and external features such as conformal cooling channels and many more. In the present, what we developed is abrasive flow finishing process. This process consists of three main elements. The first, machine tool itself. The second, the fixturing or tooling to hold the component firmly in the place to flow the medium across the surface to be polished. The third and most important element of this abrasive flow finishing system is polymer rheological abrasive medium. We have designed and developed indigenously a abrasive flow finishing system at IIT Tirupathi. The polymer rheological medium consists of many ingredients such as base polymers, rheological additives and abrasive particles. This polymer rheological medium has varieties of rheological properties, and the mostly used medium is in viscoelastic nature, which has viscous component as well as elastic component. Any viscous fluid like honey, if you take and throw, what will happen? It flow in the direction of applied pressure. However, if you want to understand elastic component, take an eraser and press it. What will happen? It try to move in perpendicular directions. These two viscous and elastic components are clubbed here and assisting to the abrasive particle. Whenever you are putting an extrusion pressure on the medium, what will happen is this viscous component and will try to move along the application of pressure. Elastic component try to indent onto the surface, because of which micro nano surface polishing will take place. So, this all depend on the rheological characterization of the medium. So, this particular medium has unique properties. That is why this is very expensive in the market. It flows like a fluid. Whenever you place a spherical ball onto the surface, it deforms with respect to atmospheric pressures. That means whenever we are applying some extrusion pressure, it can flows to the nook and corners of the complex surface and polishes it. The second, it behaves like an elastic ball. Whenever you make a spherical ball and throw onto the ground, it jumps like a tennis ball. Third, it breaks like a plastic piece. Whenever you pull very fast, it breaks into pieces. At the same time, whenever you pull very slowly, it comes like a bubble gum throughout the length. So, this shows unique properties of flow and deformation. That's why one has to study the rheological characterization. So most importantly, one has to understand viscous characteristics and elastic characteristics, for which one has to understand creep recovery test. So to understand creep recovery test, what we have performed is, we are giving certain stress and holding for a time and observing the strains. So how much stress we have to give, for which we have to do the dynamic rheology, that is, whenever you are changing the shear stress, you are observing the storage modulus, where there is no change in the storage modulus even though you are changing the shear stress. That region is called linear viscoelastic range. That means there is no breakage of the polymer chains, there is no stretching of the polymer chains. Now you can put into the creep recovery test, and A to B is viscous plus elastic and B to C is elastic recovery. Now we can understand viscous and elastic components of particular mediums. Once you can master this polymer rheological abrasive medium and the indigenously developed abrasive flow finishing system, that is, you can apply simple to the complex surfaces ranging from biomedical implants such as knee implants and other things. Nowadays additive manufacturing is applied to make complex features externally as well as internally, and small to the large components. The novelty of this particular medium is it can polish any type of complex internal passages such as conformal cooling channels, which is near to difficult to polish by any other conventional way of polishing techniques. This particular technology also can be used for finishing of drug eluting stents, which can polish properly for the manufacturing of the stents and other biomedical devices. Our laboratory demonstrates not only about publications, we patent the technologies, also developed laboratory scale to the commercial equivalent machines. As you can see, this particular abrasive flow finishing system as well as the medium is indigenously developed at IIT Tirupathi, and this shows Make in India and self-reliant India, Atmanirbhar Bharat. Jai Hind, Namaskar.